This is a short demo of the MCP Gateway exchanging an access token on behalf of an MCP client for another token that can be passed along in the request to the MCP server. So the goal here is to facilitate authentication for the MCP clients that won't have to negotiate multiple tokens and multiple authentication methods with the multiple MCP servers that it wants to call tools from, but has the MCP Gateway doing that transparently on its behalf instead. So the setup we have here includes the MCP Gateway sitting in front of a couple of MCP servers, and we're going to use the MCP inspector as the MCP client. I would like to highlight that we are using the Kuadrant project to enable, as an additional layer on top of the gateway, all the authentication and authorization capabilities we want to our gateway, which otherwise would just do a token path through to the MCP server with no validation, no token exchange, or reinforcement of any kind. However, I also would like to note that there is no hard dependency between the MCP gateway and the Kuadrant piece. In fact, there are many other ways how to enable OAuth in the gateway, such as by leveraging OAuth functionalities provided by the underlying gateway API implementation, or even leveraging the now experimental new feature of OAuth via a filter provided by Gateway API itself. The only reason why we used Kuadrant is because it happened to provide the best feature set for the use case we wanted to demonstrate, that didn't involve writing any piece of code, and yet was capable of integrating with an external OAuth server, and as well as with Hashicorp Vault, and implementing all the logic that we wanted. So in the token exchange use case, as we model it for this demo, whenever the MCP client calls a tool, the MCP gateway, with the support of the AuthPolicy, will validate the OAuth bearer token passed in the request. Here we are omitting the details of whether that token, if it's not valid, then we would respond back to the client with unauthenticated, and the client would then get redirected to the login page of the auth server. But in the case that the token is valid, then the first thing that the AuthPolicy here will do is it will check with Vault for the presence of a personal access token or API key associated with this user and specific MCP server whose tool the client is trying to access. If it finds one, then it will swap the authorization header of the request to the MCP server with this token, and that is what will be perceived by the MCP server when redirected by MCP Gateway. On the other hand, if it does not find a secret stored in Vault, then it falls back to trying an OAuth2 Token Exchange instead, which will only work if the MCP server is a trusted resource server configured in the same auth server where the original bearer token was issued, and the access token to swap the authorization header with, in this case, is the one obtained from the token exchange, from the OAuth token exchange. Obviously, this implies that the MCP server is expected to support OAuth as an authentication method as well, not to accept the original bearer token, because that's never forwarded in the request to the MCP server, but the one obtained after the token exchange with reduced scope. So other than that, the MCP Gateway and AuthPolicy enforce some additional authorization checks, like for verifying whether the user is authorized to call the particular tool, which we are omitting here in the diagram. But hopefully this whole flow will become clear while we run the demo. So here we have the MCP inspector So first thing we're going to do is we'll connect. So because there's no user session here, it gets redirected to the login page provided by the Auth server. Here we're using Keycloak, where we created a user beforehand, so the MCP user. We're gonna sign in, authorize these OAuth scopes, and with that, we should now have an OAuth access token stored in the context, which we can check by going to the Auth tab at the top here, and we could even inspect it using this CLI tool to see this is a full scope access token that lists among the audiences all the MCP servers that the user has access to, and here all the tools that the user has access to. So this is the access token that's going to be sent in the request when the MCP client tries to call a call, and that will be intercepted and swapped, by the MCP gateway. So if you go back to tools and release the tools, we're going to be using this tool here called the headers tool, provided by the test MCP server number 2, that basically echoes back in the response all the headers it got from the request. So if we run this tool, we should see here that the MCP server perceived in the authorization header what seems to be also a JWT token, which we can also inspect. So if you go here, and we should see that this is also an OAuth token, only with reduced scope, targeting only that specific MCP server. Now, moving on to the Vault, Hashicorp Vault integration use case. If we store a secret in Vault, now I have Vault here exposed, we're going to create a secret for the MCP user and server 2 combination. If you go back now and just repeat this request, we should see that the authorization header perceived by the MCP server contains the secret retrieved from Vault. And we can also revert this by deleting the secret from Vault, and one last time repeating the request to see that we're now back to the OAuth token with reduced scope being passed in the request to the MCP server. And this concludes the demo. Thank you.